We are now going to look at solving trig equations. Let me say a few quick things before we actually look at some examples. Here's the first problem I'm going to do in a minute, the most basic kind of trig equation to solve. And by the way, in solving trig equations, the angles we're looking for are going to be in radians. So for now, none of these problems will be solved in terms of degrees, but we will give the answers to the angles in terms of radians. So this is the simplest kind of equation to solve. In solving this, we think of theta as our variable. So solving this equation means I need to find the angle. If I plug it in here, the sine of the angle equals 1/2. Now before we talk about this, let me say first that there are going to be two kinds of solutions that you're going to be asked for in the homework. In other words, some homework problems, the first problems you do, they will ask for what we call general solutions. General solutions means every angle that makes this equation true. So there might be more than one angle that when you take the sine it equals 1/2. As a matter of fact, if I were to just grab the unit circle and if I began to look for which angles the sine is 1/2, hopefully by now you're pretty good at this. If I look here at pi over 6, the sine of pi over 6 is 1/2. So pi over 6 would be a solution to this equation. I'll even write it here. But that's not the only angle that would solve this equation. How about if I go over here to 5 pi over 6? What is the sine of 5 pi over 6? It's also 1/2. So as of now, if I just take one quick trip around the unit circle, there are actually two angles that are solutions to this equation. But you know what? We know from trig now, there are two solutions on one trip around unit circle, but what if I go around the unit circle, I go 2 pi, and then come back here? So one trip around plus pi over 6 is actually 12 pi over 6 plus pi over 6, 13 pi over 6. There's another solution to this equation. And if you think about it, theoretically, I can now go over here and take 12 pi over 6 plus 5 pi over 6, and I would get another solution. As a matter of fact, theoretically, I keep going around and around, and if I kept stopping here and here, those would be solutions. That's the principle of coterminal angles, which you learned about earlier. So what does that say? Theoretically, how many solutions are there to this equation? How many angles? Could I plug in here and this equation would be true? There's actually an infinite number of solutions. So that's one thing we have to take into account. So initially you're going to be given problems where you're asked to find the general solution which another word for that is like all solutions. So we have to think about all the solutions. We go round and round and round. But the second kind of problem, after we do some general solution problems, I call them specific solutions. And what they do when they first give you the problem, they will say to limit your solution, your angle, usually they say from 0 to 2 pi. So for this problem, if this was the equation to solve, and then they said only give the solutions where theta is between 0 and 2 pi, then you would only have 2 solutions. And you can ignore the rest of these because all these solutions would be larger than 2 pi. So there's going to be 2 kinds of questions you're going to be asked as we're solving these trig equations. Now what's going to happen is, especially for these problems with specific solutions, sometimes, like for this problem, if we're asked for a specific solution, the answer is pretty clear. There's going to be some problems later on where we're actually asked for a specific solution, but in order to get the correct answers, you have to still use the general solution as the first step. And once you determine the general solution, then you go determine the specific solution. So we need to understand what this general solution means, and then we can also understand specific solutions. So a general solution for this problem, we've already sort of started, right? Here's what you do. I'm going to, matter of fact, I would just show you a homework problem so you can see how they word it. Solve the equation, give a general formula for all the solutions, and then they say list 6 solutions. So let's go ahead, let me give you the general solutions, or what they call the general formula, and then we will look at this problem to see in what form they want you to put the answers. So let's explain general solutions first, and then we can look at how they want you to type in the answers. We've already started talking about this. What you do with the general solution is you find all solutions theta from 0 to 2 pi. So 1 trip around the unit circle. So for instance, this equation, the first angle we found was pi over 6. So I'm going to write down this first solution, pi over 6. Now the whole key is we have to think of a clever and smart way to say, okay, yes, pi over 6 is a solution, but if we go around the unit circle once and stop back here, that's another solution, which we called 13 pi over 6. And we could go around the unit circle twice, which would be 4 pi, and then stop here, and that would also be a solution. How can we express the whole idea of going around and around the unit circle? And here's how they do it. You take your initial solution on the first trip around the unit circle, and you simply add 2 pi times k. K is called a counter, where k equals -2, -1, 0, 1, 2, ... In other words, what this means is normally you start at 0 And your first solution is you plug in 0 for k, just so it's clear, maybe for this first one. Sometimes I'll even make a little table here. You start out with 0 for k. When I plug in 0 for k, my solution, 0 times 2 pi is 0, my solution is pi over 6. Next, I'm going to plug in 1 for k. So pi over 6 plus 2 pi, we already did that. That's that 13 pi over 6. And that's another solution. And if I plugged in 2 for k, I would have pi over 6 plus 4 pi. I also have to include negative numbers. So if I say, let's set k equal to -1, so now I have pi over 6 plus a negative 2 pi, so it's really pi over 6 minus 12 pi over 6. If you go to unit circle, it's not on here, but if I were to go to -11 pi over 6, I would go like this, and I would end up right here, which once again is a solution to this equation. So this is a shorthand, clever way to express all the solutions, all the angles that end up right here. From pi over 6 to 1 trip around, end up pi over 6 to 2 trips around. It even takes into account if you go in the negative angle direction. So this is the basis for what we call the general solution. Now this, so I said find all the angles from 0 to 2 pi. This was the first one, but there was a second one, right? On 1 trip around unit circle, we also said that 5 pi over 6 was the solution. So now there's a second general solution. So you do the same thing, except now I write down 5 pi over 6, and then I add 2 pi k again. And just so you know, from now on, when I do this kind of notation, I'm not going to write down every time this last part where k equals -2, -1, 0, 1, 2, just because it's tedious, and when you see this notation, you sort of realize that this is also included. So basically, here are your two general solutions. So once again, the idea is you take 1 trip around the unit circle, you figure out which angles would be a solution, and you take each of those angles and you add 2 pi k, and that's a general solution. And then if there's another angle, you take and add 2 pi k, and there's a second general solution. So this is a way to write the solution, to write every solution actually, every possible angle that would make this equation true. So now let's actually look at, when you do this kind of problem in the homework, what they're going to want you to do. So the first thing they say is solve the equation. And then they say give a general formula. So we've done that for all the solutions. And then list 6 solutions. So let's see the kind of thing they want you to do. So the first thing is write the general formula based on the smaller angle. See, what they're going to do is, since there are, for this problem, since there are 2 general solutions, they ask for the smaller angle general solution, and then they ask for their larger angle general solution. So for us, we would put in, for the smaller angle, since pi over 6 is a smaller angle, and then for the larger angle, So these are the two general solutions, and then the second part of the question lists 6 solutions. Then they go in and they want you to list the first 6 solutions that are greater than or equal to 0. And here's what you want to do. You want to go ahead, and I will show you what I did a minute ago. So here are my 2 solutions, my 2 general solutions. Now, since they want the first 6 solutions, I started it here. Let me go and finish it. Now, by first 6, and they actually say here, let's read the instructions so you see what the answer. List the first 6 solutions that are greater than or equal to 0. So they're only asking for positive angles, the first 6 positive angles. So I already started, what you do is this little table here, I already started it. So now we want to find the first 6 solutions. So you always start with k equals 0. When I plug in k equals 0 into this equation, I got pi over 6. Now when I plug in k equals 0 to my second general solution, I get 5 pi over 6. So when k equals 0, these are my 2 solutions. These are going to be the first 2 of 6. Now I bump up k to 1. When I plug 1 into my first general solution, 2 pi plus pi over 6 is 13 pi over 6. When I plug in 1 into my second general solution, 5 pi over 6 plus 2 pi is 17 pi over 6. Now I have 4 solutions. For now, I can ignore this because we only want positive solutions. So now, since they want 6, I need 2 more. So now I plug in 2 for k. So pi over 6 plus 4 pi. Well, 4 pi is the same thing as 24 pi over 6. So the first general solution would give me 25 pi over 6. If I plug in k into my second general solution, 24 pi over 6 should be 29 pi over 6. And these are going to be the 6 solutions. So right here in this box, you would put all 6 of these angles separated by a comma. So this is the kind of problem you're going to have when they give you a trig equation and they ask for the general formula. So this is how you do sine and cosine. Now let me talk about tangent for a minute, because I think you will have to have a tangent problem. Look at this one. They ask you to give the general formula for this trig equation. Let me explain briefly. When you're getting a general solution for sine and cosine, you always add the 2 pi k. However, if you're ever solving a trig equation and you're asked for the general solution for a tangent, just because the way tangent works, you don't add 2 pi k, you just add pi over k. So for instance, the problem I was just looking at, let's talk about it briefly. It said tangent of theta equals negative square root of 3 over 3. Now with tangent of theta, I need to go to the unit circle, and with the unit circle, I don't even have to go all the way around. For tangent, I can just go look at the top half of the unit circle and see what the solutions are. Now tangent can be sort of tricky because the way I do it is, once again, you think of tangent as sine over cosine. So I need to get some kind of fraction like this. So you do this enough and you realize pretty quickly that here's some algebra that we need to understand. There's another way to write this fraction, and this is going to help to be able to solve these problems. 1 over square root of 3 is the same thing as square root of 3 over 3. This also becomes important. Later on, we're going to have problems. If you go to the unit circle, and you notice square root of 2 over 2 is pretty common for sine and cosine, it's important to know that this also can be rewritten as 1 over square root of 2. To get from here to here, what you do is if you multiply the top and the bottom by square root of 3, then you get this. And this one, if you multiply the top and the bottom by square root of 2, you get this. But these are really the same. So when I'm looking at this, you know what I'm really looking for? I'm looking for some kind of sine and cosine that gives negative 1 over square root of 3. And you'll see why I say this, because now I'm looking to put a sine over a cosine, and I want to have a square root of 3 in the bottom. I do that because I'm going to either have this angle or this angle. Since I want the square root of 3 in the bottom, what I'm going to do is I want the cosine to have the square root of 3 over 2. Let me just do it. Let's look at the tangent of pi over 6. The tangent of pi over 6 is the sine of pi over 6 over the cosine of pi over 6. If I go to my unit circle, here's the cosine, here's the sine. So the sine is 1/2. The cosine is square root of 3 over 2. You simplify this, you get 1 over square root of 3. Now that's the number I want. However, the twist is, actually, I need it to be negative. But what I do is I realize if I go to the reference angle over here, if I were to do the tangent of 5 pi over 6, the number would be the same, except I would have a negative. So in other words, the solution to this is actually going to be 5 pi over 6. Now I said for tangent, once you find this one solution, that's all you need, because what you're going to do is instead of adding 2 pi k, when you're looking at tangents, you just add pi k. And then if they ask for 6 solutions, you just put in 6 values of k. All right, so that's the idea of solving equations and finding the general solution.